So what is multi-paradigm data science? Multi-paradigm data science is an approach to doing data science that we formulated in Wolfram research in the last 30 years, and we applied internally as well as externally for external companies. And it's data science that falls into these type of categories. So the first one, and the most important one, is it uses flexible pipelines built on arbitrary input. What I mean by that is that we use a combination of functions and methods that don't care really about what your input is, like whether it's a text or an image or a number. It could take anything and then translate into the same type of output again and again and again. And from different databases, from different sources, different files, and so on. Another thing is that it delivers better and faster insights. So because the pipeline is already set up and it's modular and you could just switch parts in it, the whole reproduction cycle is much faster. So after you set up a large pipeline for a certain website, for example, then different stakeholders in the company can come in and ask rapidly for different plots, different diagrams, different analytics, and get them very fast instead of a requirement to build a whole new pipeline and retrain everything. Another thing is to use meta-algorithms. So kind of a principle in our development and in the development of the Wolfram language, which is kind of the language we developed at Wolfram Research, is the use of meta-algorithms. So instead of an algorithm or a function doing one thing, it does 8 or 10 or 300 different things, and you don't really need to know what it does. What you need to do is that it takes the output, the input, and provides the right output. And maybe for textual data, it needs to use this type of algorithm, and for image data, it needs to use that type of algorithm, but you don't really care about that. What you care is that it provides you with the right output, and that's why the use of meta-algorithms is so important here. It's highly automated, so the selection of the algorithms, the selection of the type of feature extractor to use, which takes, for example, image data and turns it into numerical data, is automatic. So you don't need to worry about that, and you don't need to have some DevOps guy spend a month installing some libraries or some kind of programming for that specific type of task. It's scalable. So what you build in the small scale is immediately scalable for larger systems. And it's infused with real-world data, which we're going to talk about quite a bit in a second. And I think that's very important to understand how you relate the quantities and the different values in your system to the real world. So for example, let's say you get a request in from a client from England that's talking to you in pounds or in euros, and your team is working in the US, and you'd rather that automatically translate into US dollars with the current rate today. Maybe dates are very important, and we'll see dates in kind of an upcoming example. Maybe the area means something. So it's not just a zip code. It's not just a number. It's a zip code that has a meaning and has a geographical location. And I think that's hugely important, and it's something that's kind of overlooked widely, is what does the values and the quantities in the data actually mean? And the most important thing is that, of course, it delivers the right output to the right audience. So it's customized to the audience. So a person working, again, in the marketing department gets something different than a person working in operations or strategic management or any other department. And they always get that same report like they're used to getting it, whether it's an Excel spreadsheet like in accounting or in anything else, or a plot in some kind of visualization, or even maybe a program could be an output. And kind of these three things on the side here, these three nice looking graphs that are kind of based on fake data, well, except the graph analysis there because that's on a Wikipedia search, are basically kind of showing you that some groups want different data. Some only want histograms, others want more clustered analysis because they're trying to use that as a first stage. And they're all using the same type of normalized formulated data.